Hello everyone, this is Pablo from the C Sharp Academy. In today's tutorial, we're going to build a habit tracker application in C Sharp. It will be a very simple project suited for absolute beginners. So if you have learned a bit of C Sharp and haven't done any projects yet, this is the right one for you. If you have no experience or a little bit of experience with C Sharp and SQL, this is also great for you. In this application, we're going to track data about one habit of our choice. We'll design a CRUD application so we can create, delete, update, and view data about our habit. We chose Sqlite with Visual Studio so you can code without a lot of setup. And you can follow this tutorial if you're using Windows or a Mac computer. But if you're comfortable with other operating systems or code editors, you can still follow this tutorial without a problem. This tutorial is going to be very practical, so we do recommend you have watched at least a basic C# tutorial previously. There are links to my favorite tutorials below in case you haven't yet. And you also need to have the .NET environment installed in your computer. If you don't have it yet, please check the links below with instructions on how to do it. So let's get started. Okay, so the first thing that we need to do is to create a folder where our project will live. So here I already have Visual Studio Code open, and clicking on Open Folder, I open this window where I can choose New Folder, pick a name, whatever name you want, clicking Create, and now if we open it, we will have Visual Studio Code open in the folder that we want to work. The next step is to actually create the project, our beautiful console application. So for that, we're going to open a terminal. So this is an integrated terminal that we can use inside Visual Studio Code. As you can see, the directory is already chosen. And we're going to run this command, .NET new console -- name, and pick whatever name you want. Project is created. Let's have a look at what we just created. So if we open the project folder, we can see an obj folder inside it. This is used in the compilation process to hold temporary files. And we also have the program.cs, which is the starting point for our application, and habittracker.csproj, which contains configurations for the project. We also need to click Yes on this dialog to bring in the required assets to build and debug our application. That will create a bin folder, which is where our executable lives. Now let's run the app by going to Run and Run without debugging. And you will notice that if you click on Debug Console, you can see the result of running your application, which is the message Hello World printed. However, for this application, we need to take the user's input, and that can't be done through the debug console. So we will need a different strategy for this. We're going to change our configuration so that our application runs in an external terminal instead. So let's see how that's done. In the .VSCode folder, we have a launch.json file. So you have to find the console property and change it to external terminal. That means that every time your application runs now, it's going to open an external terminal. So let's run the application again and see what happens. Notice that an external terminal will be open and you'll be able to see your Hello World message printed. You can see the console is quite crowded with messages we don't want, but that won't be the case when we build our application. It will be way cleaner. So it's time to finally start coding our application, and the first step is to create and connect to the database. For that, we're going to need a connection string, which is a string that contains information about a data source. Connection strings are quite specific and also case sensitive, and the compiler doesn't warn you when you write it incorrectly, so make sure you pay attention so that you don't run into errors when connecting to a database. Now to connect to the database, we're going to need an instance of the Sqlite connection class, which will be provided by a library that we'll bring in. We're going to pass as an argument the connection string that we created. And the declaration of that class will be wrapped in a using statement. That means that we will correctly use the garbage collector that C# provides us. I'm not going to go into detail about the garbage collector and the using statement, but I'll provide a link for you to research. Then we need to open the connection. Then we need to create a command to send to the database. So we are telling the connection to create a command. We are also saying that this command is a command text, which will be an empty string for now. And then we are executing that command with an execute non-query. Execute non-query means that we don't want the database to return any values. We're not querying the database. And we are using that because we're not asking questions from the database. We are just telling it to create a table for us. And that doesn't return any values. And after the command is sent, we need to close the connection with the database. Now, the compiler is complaining about the Sqlite connection class. That's because we didn't bring this library in. It's not an external library. It's provided by Microsoft, but we still need to bring it in. And we do that using this tool called NuGet Package Manager. NuGet packages are nothing more than zip files with precompiled code, and we add them as we need in our application. So let's do that by pressing Command-Shift-P to open our command palette and choosing Add Package. If you don't have NuGet Package Manager yet, you're going to have to add it as an extension to your Visual Studio Code. After that, we need to type the name of the NuGet package, and in this case, it will be Microsoft.data.sqlite, and then choose the version. For that, choose the version of .NET that you have installed in your computer. Every time we install a NuGet package to our project, we need to restore our dependencies. So let's do that by pressing Restore in this new dialog that just opened. Now let's examine our csproj file, and we're going to see that we have it added as a dependency now. Microsoft.data.sqlite is added as a package reference. If you hover over the compiler complaint, you can see that a light bulb opens here on the left-hand side. Click on the light bulb and choose Microsoft.data.sqlite. That's going to add a using statement to our project, and now we don't have the compiler complaint anymore. The next step is to finally create the SQL command to create the database. Here I'm using the @ sign just as a standard. This is not absolutely necessary to create this string, but the @ sign allows us to create multi-line statements, which are very common in SQL. Now, the SQL command for creating the table is quite simple. Basically, we're creating a table if it doesn't exist, and the name of that table is drinking water. And the name of the table is optional. You can choose whatever you want. Now we need to say what are the properties of that table. So what columns are we going to have in that table? So I'm creating here my columns. So I'm going to have an ID column, a date column, and the quantity column. These are the properties of drinking water. Now, we're storing the date as text. There is no date type in Sqlite. It's slightly different from SQL Server if you have worked with SQL Server before. And the quantity as integer. And the notation for integer is also slightly different from SQL Server. Now, the ID property, you have a few more properties attached to it. The first one is primary key, which means that the ID will be the identifier for each record. And also we have the auto increment property, and that means that every time we add a record, the ID will increment itself. Now it's time to run our application and see what happens. As you can see, the habittracker.db was created, and that's a good sign. If you right-click on the habit tracker database, you can click on Open Database, and that will open the SQLite Explorer. If you click on the arrow next to the database and then click on the arrow next to the table, you will be able to see the properties of the table. And that means that the table was correctly created. And that's very exciting. You have just created your first SQL command successfully. Now it's time to get the user's input. Every time the user opens the application, you want to ask a question. What do they want to do? So let's see how that's done. The first thing that we need to do is to clear the console when we reach this method. And we do that just to keep the console clean and easy to read. We're getting the user's input using a loop, and that's going to be a while loop. For that, we created a Boolean, remembering that a Boolean is a property that holds two values, true or false. The condition for this loop to keep running is that the close app Boolean is false. If it becomes true, then we get out of the loop. And these are the messages that I want to send to the user. So there is a header, main menu. There is the question, what would you like to do? And then the list of options. Now the styling of this main menu is totally up to you. Just make sure that it's nice and readable and the messages are clear. I also added space between some lines. Notice that we have a backslash and n. And in the end, I added a bunch of dashes to make things more readable. The next step is to create a variable that will hold the user's input. That's going to be a string. And when a code reaches this line, it's going to wait for the user to input something, to type something to the console. Now let's add a switch statement to say what to do depending on the user's input. The argument that we're passing to the switch statement is the command input. And the cases are the cases that we're going to cater for. So in case the user types 0, we're going to have a certain outcome. So in this situation, in case the user types 0, we're going to print goodbye, change the value of that Boolean close app to true, which means that we're getting out of the loop, and then break, which means we get out of the switch statement. So now let's comment out all of the cases except for case 2, which will be to insert data into our database, insert a record into our database. In case the user types a string with the number 2, we're going to open the insert method. So let's create the insert method. Notice that we have a private in front of the method, and that's going to be the access modifier. Don't worry too much about those now, since we still have a small application. But that means that this method can only be accessed from inside this class. I like to keep my methods small. So we're going to access another method called getDateInput to get the input for the day. Now in the getDateInput, we're actually getting the input. So we're printing a message saying exactly what we want and storing the input in a date input string. Notice that I'm being very specific about the format of the date. And that's because in the last part of this tutorial, we're going to add validation to prevent the users from inserting incorrect dates. We're also telling the user that if they type 0, they can return to the main menu. And this method is supposed to return a string, as you can see in its signature. So for that, let's return the date input string. Next, we're going to need input for the quantity of water that we want to store. For simplicity, I'm not allowing split numbers in this application. And I'm leaving it open for the user to choose what type of quantity that is. Is it glasses? Is it bottles? It can even be liters, but we would have the limitation that we can't use split liters. For that, we're creating a getNumber input and passing a message to it. And we're passing a message because we're going to use the same method later to collect the input for IDs of the records. So we're using the same pattern that we used for the getDate input. This time we're returning an integer, as you can see in the signature of the method, and then we're printing a message, and the message is going to be the string message that we're receiving as an argument. We're receiving the user's input as a string, number input string. We're checking if the input is 0. If it's 0, we get the user input again, going back to the main menu. But then we need to convert that string to an integer. And we do that by calling the convert dot to int32 and passing the string to be converted. Now that we're getting the input for the date and for the duration, let's insert it into our database. So the pattern is going to be the same. We have a using statement, we open the connection, we create the command, we execute it, and then we close the connection. Now, when we insert the connection, we need to also insert the input from the user. And we are using string interpolation for that. So notice that we have this $sign in front of the string that allows us to pass parameters, pass variables. So in between the curly brackets, we're passing the date and the quantity, but don't forget the single quotes around the date, but no single quotes around the quantity. Now, if you hover over the connection string, the compiler is saying that the name connection string doesn't exist in the current context. And that happened because I declared this string inside the main method. That means that it can only be used inside the main method. So let's declare it outside in the scope of the program class. And then we need to declare it as static. Otherwise, our static methods won't have access to it. Now let's add the getUserInput method to the main method so that it gets called when the application runs. Let's see if everything works by running the application again. As you can see, a console was open with the messages that we want, and now it's waiting for our user input. So I press 2 to insert record. I put the date. I'm inputting the quantity. And how do we check if it worked? I'm going to right-click on the table, ask to show table, and then on your top right, you can see that the record was added. Success! Our insert method is working. Now let's take care of showing the table to the user. Let's uncomment the getAllRecords method and make sure that the case is a string with the number 1. So now let's create the getAllRecords method using the same template that we used before. We're going to clear the console for organization and add a using statement for the Sqlite connection. Then we need to open the connection and create the command. Notice that the SQL command here is very simple. Just selecting all from the drinking water table, selecting all columns. The next step is to create a list where we're going to store the rows of our table. So we need to bring in the system.collections using statement to be able to use that list. And notice that's going to be a list of drinking water. What's drinking water? Basically, we had to create a type. And that type is going to be called drinking water. Remember that C# is a type-strong language. And it encourages the creation of types to handle all sorts of data. So this is going to be a type that represents the drinking water. We're creating this type as a different class, but in the same file. So that's outside the program.cs class. The alternative to that would be to create an anonymous object every time we read from the table. But just to make things more organized, let's use a strongly typed object. Now we need to use the Sqlite data reader to read the data from our database. Notice that when you hover over the method, you can have an explanation about it. That really helps when you're coding along so you can understand everything that's going on. Now we need to add a bit of code to read the data from the database. After we execute the reader, if the reader has rows, we're going into a loop. And in this loop, while the reader is reading the lines or the rows for this table, we're going to add a new record, a new drinking water object to our drinking water list. When there are no more rows to read, we get out of the loop and we have all the rows stored in our list. Now we need to tell the reader what type of data we're getting from the database. In the case of the ID and the quantity, we're getting an integer. So we're using the getInt32 and the number of the column. In this case, 0 is the first column and quantity is the third column. So it has an index of 2. Now to get the date, we need some parsing. Remember that the date is stored as text or a string. So we need to get that string, reader.getString, with the number 1, because it's the second column. And then we are wrapping that with the datetime.parseExact. What does that mean? That means that we're trying to show the date with a very specific format. The day, the month in numbers, and the year with 2 numbers only. We're also passing the culture info. And that's because the format of the date depends on the language and the country where it's being used. Now, if our table is empty, the reader.hasRows boolean is going to be false. And that's the condition for our if statement. In that case, our code will reach the else block of the statement. And when that happens, we're printing no rows found. And after that, of course, we need to close the connection. The next step is to loop through the table and show each row. I'm using a string interpolation to add the properties that I want, the messages that I want to my string, the string that I want to print, and I'm also parsing the date into a string with the format that I want, with 4 digits for the year instead of 2. So now if I run the application and type 1 to view all records, I can see my records with a nice format. So now let's take care of the delete method. Let's create it below the other methods and call the getAllRecords method so we can show the table to the user. It's nice to show the table so the user can see the records and grab the ID for the record they want to delete. We're getting the input using the same method we created before, getNumberInput, passing a different message, and storing it in a variable. Then we are creating the connection, again inside a using statement, and we're creating a delete command. And again, we're using string interpolation to pass the ID of the record we want to delete. And then we are executing the command. Now, the execution of this command doesn't return any records or values from the table, but it does return the amount of rows that were affected by that command. In this case, if the row count is 0, which means that no rows were affected by that command, the record doesn't exist. And we're going to tell the user that the record doesn't exist, so the user has the chance to try again. In case the record exists, we're printing a message saying that the operation was successful. And we're calling the getUserInput again, so they can go back to the main menu. Then we need to uncomment case 3 in the switch statement. And let's try the application again. So I'm typing 3 to delete a record. The table gets printed. I choose a record. And let's see if it was deleted. When I type 1 to view all records again, I get no rows found because I deleted the only record from my table. Now we need to take care of our last CRUD operation, and that's the update. So let's uncomment the update case. We're calling the update method when the users input the string 4, and then let's create that method. That method is going to follow the same pattern of the previous ones. We're going to clear the console, show all records to the user so he can pick which row he wants to update, and then get the number input. We pass a specific message related to updating the record, and then we open a connection to use the ID input. Now, since we are updating the record, we need to get the date and the number input again for date and quantity. And for simplicity, let's just make the user update both fields. In a real application, especially with more properties, you wouldn't force the user to update every single property. For simplicity, let's keep it this way in this application. Now, before sending the update command, we're creating a different command just to check if that record exists. Then we're using for the first time the execute scalar method. And that's because we actually want a value returned from the database. So we are executing that command. We are converting it to an integer. And that command returns 0 for false or 1 for true. So if check query equals 0, that means that we don't have any records. The reply from the database is false. If that's the case, we're going to close the connection and run the update method again. If that's not the case, we're going to reach the next part of the code and get the date input and the number input again for the date and the quantity, and then send the update command. And we're using the date and quantity properties in string interpolation to insert the data. So let's run the app and see if it works. First, I'm inserting a record since my table is currently empty. Now I'm typing 4 to update record, 3 as the ID of the record I want to delete, and then I have to insert the date and insert the number of classes again. So I changed the date from the 25th of February to the 24th of February successfully. So now I'm going to remove the console.clear from the update method because I want to be able to see what happens if I type an ID that doesn't exist. So let's try to do that. Let's run the application. Let's type 4 for update record. And when it asks for the ID, let's type 4, which is an ID that doesn't exist. If I do that, I can see record with ID 4 doesn't exist. So our validation is working correctly. Now we need to add a default case to cater for the situations where the user inputs something other than 0 to 4. If that's the case, we're going to return invalid command and tell the user that they need to type a number from 0 to 4. So if we run our application again and try an invalid command, it's going to return the correct message. It never lets me type anything different. Now let's try something different. Let's try to insert a record with an invalid date. Let's say a date with 14 as a month. At the moment, it's allowing me to do that. So it's asking for the number of classes, and the application doesn't break. However, when I try to visualize that date, remember that we are passing the string that gets returned from the database into a date time. So we get an error because we can't parse that string because it doesn't have a correct format. So let's see how we're going to fix that. In the getDateInput method, we need to add some validation. So how we're going to do that? We're creating a loop, and the condition for that loop is while the date cannot be parsed, and the format for the parsing is exactly the one that we expect from the user. So while that doesn't happen, the code inside the loop keeps running. And inside the loop, we're telling the user that the date is invalid, and we're getting the user input again in the same variable that we created before. And we have to do the same thing for the quantity method to get number method. At the moment, the application breaks if we try to input anything other than a number, and we're also allowing the users to input negative numbers, which is incorrect. Let's just add one more thing before testing. Let's make sure that the program stops running once we hit 0. At the moment, it finishes the loop, but it doesn't stop the application. So we're going to use environment.exit 0 for that. And now let's run some tests. So the first thing that we're testing is the delete method. So if I try to delete a record with ID 8, I get the correct message. Record with ID 8 doesn't exist. Then let's test finishing the application by typing 0, and that works, gives me goodbye and stops the application. And if I run the app again and try to insert a record with an invalid day, it gives me invalid date. And if I try to input an incorrect quantity, a -1 or a string instead of a number, I also get an error. So that's it. The application is complete. The validation is done. Please subscribe to the channel if you liked the video. This is just the first of many beginner-friendly tutorials that we have planned ahead. If you have any questions, please ask in the comments and join our Discord community so you can ask more questions and talk to other people that are on the same journey as you.